Hi, Integrated Math 1. Welcome to lesson 5.3.2b. We're still proving triangle congruence theorems. Last time we did SSS. Today, we're going to be talking about ASA and SAS. You might already be able to guess what they stand for, but we're going to get into the nitty-gritty details today. So our learning goals today is to look at that side angle side congruence theorem and that angle side angle congruence theorem. When do we get to use them? How do we know we get to use them? So those are our key terms as well. Side angle side congruence theorem. We're also going to talk about something called an included angle. Important. Angle side angle congruence theorem, ASA, which means we're going to talk about something called an included side, also important. So we've already proven triangles are congruent with SSS. Can we do it with SAS and ASA? See what we can do. So page 150 and 5-150, it's where you should be in your book. I'd like you to consider two triangles that have two sides and an included angle congruent. Now, when we say included angle, it's kind of down here in the corner here. An included angle is the angle formed by two sides of a triangle. So when I say an included angle, we're literally talking, so if I'm talking about like this side and this side, we're literally talking about the angle in between those sides. So it's not any angle of my triangle. If it's an included angle, it's the angle between the two sides. That is really important because this relationship takes us to the side angle side congruence theorem. We often refer to it as SAS, and it states that if two sides and the included side, I can say this right, if two sides and the included angle of one triangle are congruent to the corresponding two sides and the included angle of a second triangle, then the triangles are congruent. So here I have two triangles. Can you prove to me that these triangles are congruent? Hit pause, jot down your thoughts on this, hit play to keep going. So hopefully you treated this similar to the way we treated the SAS stuff yesterday. So we said that AB is congruent to DE, so I wrote that down. It looks like AC is congruent to DF, so I have that as well. But notice angle A is between those two sides. So, and same thing here, right? So I'm just going to put matching marks. AB is congruent to DE. Angle A is congruent to angle D. They have matching marks as well. And side AC is congruent to side DF, so I'll write that down also. Two sides, the included angle in between, right? Two sides, the included angle in between, that's a good sign. That means that these triangles are congruent by SAS. Order matters. So I can say triangle, if I name this one ABC, I have to name the other triangle DEF because the A's and D's match up, B and E matches up, C and F match up. So fine, I can say that triangle ABC is congruent to triangle DEF by SAS, side angle side, side angle side. Notice it's the angle included between the two sides. Awesome. So you just proved the triangles are congruent. Good job. What about all the other corresponding parts? We talked about this yesterday. Go ahead, hit pause, write down all the other parts that must now be congruent. If my triangles are congruent, what else has to be congruent? Hit pause, write it down, hit play when you're ready to check your work. So we already said triangle ABC is congruent to triangle DEF, and we already know AB goes with DE, angle A goes with angle D, and AC goes with DF. So let's write down the other parts we know, because if my triangles are congruent, corresponding parts of congruent triangles must also be congruent. So by CP/CTC, I can say that BC should be congruent to EF, right? That's fair. By CP/CTC, I can also say, hey, angle B should be the same as angle E. Those guys should be congruent to each other. By CP/CTC, I can say, hey, angle C should also be congruent to angle F. My triangles are congruent. All the other bits must be congruent as well. That's fair. So now that you got a feel for this side angle side, let's talk our last one here. Angle, side, angle congruence over on page 152. Let's consider two triangles that have two angles and an included side congruent. We're going to use this criteria to prove two triangles are congruent. It's very similar to side, angle, side, but notice it's now angle, side, angle. That, you know what this means. Included side, if it's an included side, here I'm just going to draw a triangle here. That means I've got two angles and the included side is the side between those angles. It's a side right in between them. It's not any old side of my triangle. It has to be the side included between them. True story. So because we now understand this relationship, we can refer to it as a theorem. Angle, side, angle congruence theorem. We usually refer to it as ASA, just to make it a little easier on ourselves. And it states that if two angles in the included side of one triangle are congruent to the corresponding two angles in the included side of another triangle, my triangles are congruent. So if two angles in the side in between are congruent to two angles in the side in between of another triangle, my triangles must be congruent to each other. So page 152, take a look at my triangles. Prove to me that those triangles are congruent. Just like we did with the other one. Hit pause, work it out, write it down, hit play when you're ready to check your work. All right, so I'm going to write down what I know. I know a whole bunch of things, right? I know angle G is congruent to angle Q, so I wrote that down, right? They have it marked. They gave that to us. What else do I know? Ooh, I got a side right here. GF is congruent to side PQ. I wrote FG, but that's all good. It's all good. These two sides are congruent to each other. Awesome, awesome. Ooh, and there's another set of angles, right? Angle F and angle P, those guys are congruent to each other as well. So angle F is congruent to angle P. Awesome. I've got two angles and the included side, which matches up with two angles in the included side of another triangle. So guess what? Triangle FGH must be congruent to triangle PQR by ASA. Angle, side, angle. Because I have it on both of these, I get to say those triangles are congruent. Well done. Well, guess what, guys? If my triangles are congruent, and I have it written down here, please remember that order matters, by the way. If I start with F, I have to start with P. So if I go F to G to H, I have to go P to Q to R. Order matters in our congruent statements. We've got to make sure everybody matches and lines up. So I have that still here down here in the corner just to kind of help you out a little bit. Well, now that your triangles are congruent, what else must be congruent on these triangles? Hit pause, write it down, hit play when you're ready to check your work. All right, let's do this. So I said, okay, we already knew G and Q. We already knew GF went with P, or FG went with PQ. We already know angle F goes with angle P, but I know a few other things. So now that I have this, I know my triangles are congruent. I know a few other things. By CPCTC, my corresponding parts of congruent triangles must be congruent, which means this little side here, GH, should be congruent to QR, right? Those sides should match up since my triangles are congruent. That means side HF should be congruent to side RP. I'll call it RP. If I go H to F, I should go R to P, right? I'll do RP. Angle H should be congruent to angle R, right? Sweet. So if my triangles are congruent by corresponding parts of congruent triangles, all my other butts must be congruent too. Yay. So you now know 3 different ways to prove triangles are congruent. You have the SSS, side-side-side congruence theorem. You have SAS, the side-angle side congruence theorem. And you have angle-side angle congruence theorem, also known as ASA. And like I said, usually when we write it, we just write SSS, SAS, ASA, because we're math people and we're lazy like that. So we have these lovely 3 theorems, and they work great. They work really well, and you can use any of them to prove triangles are congruent. If those parts are the ones that match up, you're like, awesome, those triangles are congruent. That's going to be helpful on your homework, just so you know. But now we have Juno over on page 153. And Juno wonders why we can't use AAA. I mean, it's great insurance and all, but why can't I use it for my triangles? Why AAA isn't listed on my list of theorems? So I would like you to provide a counterexample. Remember, a counterexample just proves something is false. It proves something is wrong. Can you give me a counterexample to show why we can't use angle, 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 why it's not a triangle congruence theorem? Can you draw an example, maybe help me out a little bit here? Hit pause, draw your example, hit play, and see what I've got. So I thought, okay, same angles, different sides. So I thought, all right, I'm going to draw an equilateral triangle, 60, 60, 60, right? And another equilateral triangle, 60, 60, 60. Check it out. My angles all match up, right? That angle goes with that angle. This angle goes with this angle. And I'd be like, that angle goes with this angle. The angles all match up, right? I've got angle, 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 right? But these triangles are clearly not congruent. This guy is way bigger than that one. So that's why we can't use the angle, angle, angle to prove that triangles are congruent. It just doesn't work. So now Juno's like, okay, what about SSA? By the way, never, ever, ever put ASS on your paper. You should not be swearing at your math teacher. That's not okay. So we're going to refer to it as SSA. But Juno's like, why can't I use it? Why no SSA? Why is that not on my congruence theorem list? So again, can you provide a counterexample as to why that's not going to work? This one's a little more complicated, but I got faith in you. See if you can draw an example for me. Hit pause, draw it out, and then hit play, and I'll show you what I've got. So I actually, as all the weird things, I actually used a circle for mine. And this is going to look confusing, but let me explain. I have a little triangle here. I have a big triangle here. So if I draw, this is not going to be my finest drawings. I'm going to draw the little triangle. Oh, that's a terrible drawing, but pretend like I did it better. And then I'm going to draw the big triangle, which again, not my finest, but we'll pretend like it is, okay? I can see that they share this side. So I know that side is congruent to that side. This is a radius and this is the same radius. So I know this guy and this guy are congruent. So I know this one and this one match up. They also share that angle B over there, don't they? So that angle and that angle matches up. Oh my gosh. Those are definitely not congruent. I have side, side angle, side, side angle. But because my angle is not included anymore, it provides this like hinge point over here, right? It could be here or I could swing it back there. And that totally changes. That totally changes my triangle. Those are definitely not congruent. So that's a nice counterexample. You may have something similar, but that's a good counterexample for like, that does not work. So no insurance and no swear words, all right? No AAA, no SSA or ASS, neither of those. They're not okay. So those cannot be used to prove triangles are congruent. It's very sad. So stick to what you know. Stick to SSS, stick to SAS and ASA. You can use those three to prove triangles are congruent. That's going to be helpful on your homework. That's going to be helpful on your upcoming quiz. So make sure you know them well. As always, if you have questions or concerns, come talk to me. I'm around. You know this. Come see me. And I'll see you guys soon. Bye.